All right, good morning. It says it's an update on OpenHPSDR software for Linux, but what I'm actually going to do is announce some new software for Linux that I've been working on for a few months. And those of you that know the Raspberry Pi software that I wrote, piHPSDR, you may have noticed things have slowed down on the development of that. That was really because I've been spending a lot of time working on this project. I had some older versions of Linux software that some of you may be aware of, GHPSDR3 and others. Basically what I wanted to do was start with a base from the Raspberry Pi software, but I wanted to be able to have multiple receivers. And that's what I've been working on. Let me move along. Where's that not working? Okay, that's all right. No, we're okay. I'm all right. Don't worry. Okay, all right. Okay, so this new software is, I've just called it LinHPSDR for Linux High Performance Software Defined Radio. It's a new open source development. It still uses WDSP, DSP library from Warren that I've ported over to Linux. You may have seen a couple of changes to that over the last few months as I've been keeping it updated. Support for up to 7 receivers depending on the radio. Some radios can't handle 7 receivers. I have asked or put forward an idea that somehow the firmware can tell me how many receivers are currently being supported so that I know how many are allowed to open up. Support for 1 transmitter. Okay. Supports both Protocol 1 and Protocol 2. Okay. And it's written in C. It's using the GTK 3 toolkit pretty well, as I have done with other things before. It also uses PulseAudio. And that does allow us to route audio between applications. So I'll come into that a little bit more. And we also have CAC control over TCP/IP for each receiver. The plan is to put some CAC control in there over a serial port or USB serial port connection, but still some thought as to how that's going to work, because what receiver does it actually control? So there's a little bit of thought being needed there. Okay, let's have a look at it. When it first starts up, it goes out and tries to discover any HPSDR compatible devices that are on the network, and it looks on all interfaces. So if you've got Wi-Fi running as well, you may see the same radio on Wi-Fi and on a fixed Ethernet connection. And here's an example. It's come up, it's found an Orion 2 running Protocol 1. Tells me what version it is. That happens to be an N6LYT DLE. Then it's found an Angelia on running Protocol 2. That's an N100D that I've got. And the other Orion 2 is actually a bare Orion 2 board just sitting without anything else attached to it. But it will come up with a full list, and then you can basically just select which one you want and press Start Radio. And you can run multiple copies of this. So if you've got more than one radio, you can have one copy running one radio, one another. I did look at one point of having the software support multiple radios in one application. But I started to run into problems with the number of channels in WDSP, and I thought, well, I don't really want to keep adding and adding, so let's keep it separate. And it's actually easier to write the software and control the radio that way. Okay, clicking on Start Radio brings up 2 displays by default when it first starts. The top one there is a pan adapter for the transmitter. So I've done a separate pan adapter. It doesn't, if you like, use the pan adapter of the receiver like it does in other applications. There's a couple of controls on the top one. There's a MOX, one to enable Vox, to tune, a configure button to bring things up, another one that says add receiver. So you can click on that and it pops up another receiver. And it will go gray when there are the maximum number of receivers active. You know? And this works with Protocol 1 and Protocol 2. Happens to be easier to implement in Protocol 2 because of the way that's done. But in Protocol 1, have to do a little fiddling around, especially if you delete a receiver in the middle of your list of receivers, if you like. And the second one is the receiver coming up. Anybody that knows piHPSDR can probably see that it's based on some of the design of that. One of the things that's different here is the split between the spectrum display and the waterfall can be dragged up and down, so you can have it more or less. And you can actually, there's nothing to turn it off, there's no switch to turn it off, but you can just drag it all the way up or all the way down if you want to get rid of the waterfall, and it actually stops sending information to it once it knows it's too small. There's an S meter. I'll go into a bit more detail about all the functions on there in a minute. Okay, as I said, the add receiver button will just pop up more receivers. So you get more receivers. One of the questions somebody did ask me is why didn't I use a multiple document interface type thing where you've got one window with all this sitting in there. That works quite well, but the problem is a lot of people now have got more than one screen, and that doesn't really work well with multiple screens, whereas with this I can drag one, put it on one screen, another one on another screen, and when you exit the application, it remembers where everything was. So next time you start that radio, it will come up in the same position where you had it all set up before. If the radio has multiple ADCs, then you can switch which ADC the receiver's running on. Let me go into that a bit more in a minute. Here you can see you can resize the screen or the window. You can drag that grab bar between the pan adapter and the waterfall and have whatever size you want. You can make the thing full screen if you want. And of course you can have up to 7 receivers all running concurrently, all on different frequencies. And I'll talk about the filter settings for being able to receive multiple frequencies at once. And then down on the bottom right, I just brought up the display to show how much of the system's being used. This is a fairly old Intel i5 processor, quad-core, and you can see definitely using under 50% of the system to run 7 receivers. One of the things I've done is a little zoom button on the top that you can zoom in 1, 3, 5, or 7 times. Yeah, and the reason it's done that way is to make it simple to write the code. Because if it's, it always displays the middle frequency where you're at. So I just grab the middle number of pixels out and display it. So here you can see a CW signals, and in the bottom one I've zoomed in 5 times, so you get a bigger picture of it. Sample rates up to 384K using Protocol 1. And using Protocol 1, all receivers are at the same sample rate. So the actual control for setting the sample rate is in the radio dialogue, if you like, or control. Whereas on protocol 2, where each receiver can have its own sample rate, the control is actually in the receiver's dialogue. So it moves around depending which protocol you're running. And I mean, just to be aware that trying to run 7 receivers at 384K on protocol 1 tends to bring the radio down on its knees because it can't transmit that much data across the network interface. Protocol 2, we've got gig Ethernet, we can actually get higher speeds, and we can have a receiver up to 1.5 meg wide. And the example there is just showing 384K, in other words, a whole of 20 meters. So I think there was a CW contest going on that day, judging by all the CW activity down the bottom. I decided to use PulseAudio in this because I wanted to see how we could interface this application with other applications like WSJT-X, seen as FT8 is so popular now. One of the things with PulseAudio is that you can actually define some pseudo devices. So you don't have to connect using a physical sound card. So in this example here, I've actually defined 3 receiver audio channels, RX0 audio, RX1 audio. Let me see if I can make this work. Yeah. RX0 audio, RX1 audio, and RX2 audio. And then I can connect a receiver to one of these outputs and some other application to it to receive that data. It's all very simple, he says. And basically, there's just a few lines in a configuration file that will set that up. Let's go, yeah. Sorry, I've gone backwards. Yeah, just a few lines to set this up. And I've also done one for the transmit audio. So I can have an application like WSJT-X define that its output audio goes to the TX audio pseudo channel, and then on LinHPSDR, I can have the transmit audio reading that data for the output. So no wires, and all very simple. And basically, you can see here, if you right-click on a receiver, it pops up the configuration thing, but selected for the receiver that you've actually got running. And down the bottom here, you can see I've selected that I want the audio to go to RX0 audio and to enable local audio. Yeah, so it goes out there. Otherwise, the audio is just sent back to the radio. And the audio going back to the radio comes from the currently active receiver. So if you've got 7 receivers, the one that you make the active one by clicking on it is the one that the data that goes out, or the audio data goes back to the radio. Yeah. And then in PulseAudio, there's a volume control, and that basically lets you select things. So LinHPSDR is running, and it's outputting audio on RX0 for RX0, sorry, and I've selected that it goes to that pseudo RX0 audio channel. Yeah, and then on here we can see that it's transmit, and it picks up its transmitter audio by monitoring the TX audio channel. Yeah, so anything that's written or any audio that's sent to TX audio then is heard by the application. And in this example, I've got WSJT-X running, and it's receiving by monitoring RX0. So you just join them together. Very straightforward, he says. Okay, let's just look at some of the configuration stuff for a receiver. If there's multiple ADCs, you can select which ADC you're connected to. There's a simple thing for selecting band, mode, which filter you're running, and whether you're running local audio or not. You can set the pan adapter and waterfalls frames per second. They're locked together at the moment. I was thinking of having them separate so you could have the pan adapter running at one rate and the waterfall at a different rate, but I haven't done that yet. And then you can set the high and low settings for the two of them. The waterfall, there's an automatic setting where it works out what it thinks is a reasonable setting to give you a nice waterfall looking. And there's, at the moment, I've got the simple equalizer enabled, implemented. So there's just low, high, middle, and high. There is a more complex equalizer. I just haven't got around to implementing that yet. And at the top, we've got this thing that says TX frequency. Use this receiver's frequency. You can enable it. So you can select which receiver is actually controlling the transmit frequency. Okay, the frequency on a receiver can be changed just by clicking on the signal in the pan adapter and it moves to that. Or you can click and drag with the mouse over the pan adapter or waterfall. Yeah. With the mouse pointer over it, you can use the scroll wheel. You can also put the mouse pointer on the digits of the VFOA and VFOB frequency and scroll those up and down as well. So very quick frequency changing. Haven't bothered to implement a keypad to enter the frequency because it's so easy to do with this. And a lot of the controls, if you right mouse click over them, it pops up a little pop-up menu so you can make a change in selection. You don't have to go all the way back to the configuration. In both of these, the actual pop-up has been cut off when I screen grabbed that thing. But so for the modes there's a lot more modes going down than you can see on there. And the same with the filters. So mode filter, the noise blanker, and MB1 and 2, and NR1 and 2 are implemented. The AGC, slow, medium, fast, etc. And then zoom and the step size, which is what it will step the frequency if you use the mouse wheel, can be changed by using those.
Is that folder restricted to 2.7Ks?
No, I said it's not all listed there.
Oh, okay.
I said they got cut off when I screen grabbed them. Yeah, so. Okay, you can, if you have the mouse over the AF gain or the AGC gain, you can click it to move it or use a scroll wheel to move them, increase or decrease them. I added a concept of bookmarks. So there's a bookmark button, if you like. If you right-click on that, it pops up a little dialog that allows you to enter a bookmark. Saves the frequency mode filter, and by default it sets the frequency as the name, but you can change that. Yeah. And then if you left-click, it brings up the list of bookmarks, and you can just scroll down the list and double-click on one, and it sets that frequency, mode, and filter for you on the receiver that you've done this on. If you right mouse click on any of these, it pops up a thing to allow you to edit it. Yeah, so you can make changes, delete it, whatever. Well, that time's gone quick. For transmitting, as I said, there's a separate pan adapter display. The microphone level shows what level signal is coming in. The red line is actually the Vox point on the line. So if you've got Vox enabled, if it goes over that, then transmit comes on. And there's a microphone gain and a drive, and it's up to 100%. It's not the power, so it's between 0 and 100. So if you're running like an 8000 and you've got it configured that 100% is 200 watts, then 100% is 200 watts, not 100 watts. Okay. When you transmit, you'll see the pan adapter for the transmitter come on. This is actually running FT8 at this time, and it's transmitting something. And it shows you output power, SWR, and the ALC pop up there. And then also the frequency goes to red, and also the frequency goes to red on the receiver that's being used. And the receiver that is being used to control always has the VFO A or B if you're running split in red to show you that that is the one that's being used. Okay, and then there's a transmit configuration that lets you select the where the microphone input comes from. Yeah, so where the tune output level, or to use the drive level for tune. So you can set it, the tune output will just be 10% of what you got the drive level set at. Set the TX filter, yeah? You can either manually set it here, or one of the options is to use the receive filter. Whatever the receive filter is set, and it sets the transmit output filter to. And then there's some settings for FM, AM, the CT, CSS frequency if you want, and then controlling the pan adapter, frames per second and high and low, and also, again, the 3-level equalizer for the microphone input. Okay, for the radio, you can set up what the radio type is, and that does make some differences to some of the configuration options. And then you can set if you've got Alex filters or none or whatever. Set the sample rate, because we're running protocol 1 here, it's the sample rate for the whole radio, not for each receiver. And then for each ADC, you can select which antenna it's coming in, is using, whether the filter settings are automatic, or you can set them to manual, and then you've got a set of options to select which filters you want to use. So if you're running 7 receivers, you often want to set the ADC that most of those receivers are running on to have no filtering at all, so that you can get the signals through and see something. Otherwise, if you're looking on, say, 80 meters and you've got the filter set for 20 meters, you're not really going to see much. Well, I'm running out of time. CAT enabled, as I said, we have TCP/IP CAT interface working. You can set the base port, and that would be the port for RX0. RX1 will be 19091 in this case, and so on. And I'll just skip PA calibration, very similar to what PowerSDR does. Open collector outputs you can set for each of the bands. Transverter, you can set transverters up. And here's an example. 3 receivers running, one running FT8, another one FL Digi, and another one slow scan TV one, all running concurrently. I have 2 screens, which is why it looks like that when you grab the whole lot. Okay, the beta version is being released. It's actually now out on GitHub at that address. So, ongoing development, pure signal is in process, and a remote thing client, so you can run this thing remotely. I'm almost out of time. Just want to say special thanks to Warren for WDSP. Saves a lot of work. Steve Wilson, Steve's there. Yeah, Steve wrote the CAT code and has done quite a bit of help in testing. And Ken Hopper, N9VV, he's done a lot of testing for me. So, I get several emails a day saying, it's crashed, it's crashed. Okay, just very quickly, development of the piHPSDR is slow because of this development going on. Some improvements that we've done in this, I'm going to backport into the piHPSDR code. And most changes recently have been to support the Radioberry. I don't know if people have noticed that. Or how many people know about the Radioberry? Yeah, okay. This is just a simple little hat for the Raspberry Pi, and it's basically a HERMES light on a little card. Is Johan here? Ah, there he is. Okay, we haven't met yet. Johan at the back, he's been doing or designed this card, and he's been making changes to piHPSDR and giving them to me so that we can support it. And it's just a great little card. I mean, it's it's an Intel FPGA 12-bit ADC, 0 to 30 megahertz. Works with a modified version of piHPSDR, and it also has a HERMES-like emulator as well. So you can just run the little thing standalone, if you like, and have an emulator running and connect to it from PowerSDR or whatever you want to. And one last thing. Christoph, DL1YCF, has been working on a port of piHPSDR to the Mac and is very close to making that available. So we'll have some code working on the Mac. I'm hoping that the work he's done on that I can then take and we can get LinHPSDR running on the Mac as well. So, just over. I started late though. That's my excuse. So, questions?
Thank you very much. For the sake of time, I would...
No questions? Okay.
No,
One
question. Okay.
This thin client you mentioned, is this for remote station?
Yeah.
So that
Should hopefully we'll have it running on Android, iPhone, iPads, a version of the piHPSDR hardware as a thin client remotely, a laptop or whatever you want. Yeah. So that's work in progress, though. It's not going to be there for a few weeks. Okay.
Okay. Thank you very much.